Hello, welcome back. Today we'll be talking about common data structures found within Java. So for the first two videos, we've been talking about variables and the different data types. And in programming, these pieces of information and data are stored in a variety of ways, commonly in data structures. So today we'll talk about the four common data structures within Java: arrays, array lists, linked lists, and stacks and queues. So first, let's start off with arrays. And first we'll draw a one-dimensional array, which just means up in one row. So I'm just going to sketch it out really quickly, and let's allocate 5 slots to this array. So we have 2, 3, 4, and then now we have 5 slots for this array. So there are some important things to realize about arrays. So firstly, the size cannot be changed. So since we already said that this array has 5 slots, we cannot go ahead and magically add a sixth one. Additionally, arrays can only hold one type of variable. So let's say in each of these slots you have a string. You cannot add a double to it later. And similarly, if they're all doubles, you cannot add a string to it later. However, remember the example we were talking about with doubles and integers? Let's say you had a whole array filled with doubles, then you could add an integer because an integer can automatically be converted to a double. But if you had all integers, you cannot add a double because they're not the same and they have decimals. And then lastly, one important thing to realize is that it's in programming, all counting starts from 0. So this is the index of 0. Index means position. So if you're trying to refer to the object or data that's stored in this, you would refer to it as the 0th index or 0th subscript or 0th position. So this would be 1, this would be 2, this would be 3, and this one would be 4. So what we realize is that there are 5 slots in total, but the reality is there are only 4 indices, or the indices count from 0 to 4. So the max subscript that you can have, or max index, is the length minus 1. So now let's go to BlueJ and let's see how we can actually program this. So let's full screen and let's call this a new class called data structures. And then again, it's going to give you the starting code and you can just delete it. And what we're going for here is I already have it copied and pasted, but it's public static void main string flat brackets args ending parentheses and then curly brackets, and after we put a couple indents, this is where we'll be programming. So now let's actually talk about how we initialize and declare the arrays within our program. So if you remember from our earlier videos, declare just means to create a variable but not really assign a value to it. So now it's in the memory, but it doesn't really have any value. But the opposite is for initialize, and that means create the variable and also assign it a value. So now let's see how we actually do this within our program. So for declaration, there's only one way that you can do it within Java, and you do the type of the variable um, or data being used. So for instance, string, double, integers, or booleans. And then you put empty brackets, nothing inside of the brackets, and then you put the name of the array you want, or the name of the array. And then you just put a semicolon at the end. So an example of this would look like string, and then empty brackets, and then names. And that would be how you declare a variable, an array named names, filled with string elements. So now regarding how to initialize these arrays, there's two main methods that you could use. So firstly, you put the type of the data being used, so strings, integers, booleans, and then you put brackets, empty brackets, and then you put the name of the array you want, and then you put equals, and then you put the word new, and then you put the type of the data being used, and then you put the size of the array here. And in here goes the size of the array. So let me give you an example. So string, let's say that's what we want it to be, and we want it to be called names, and we want there to be 10 string elements. So we put new string, and then inside this bracket, we put 10. Remember, the indices will only go up to 9 because it starts counting from 0, but there will be 10 slots. And then the second method, it's by directly putting in the values. So in this case, it's going to give you 10, it's going to give you 10 slots, but they're all the slots are going to be filled in with just empty string, empty quotation marks. So let's show you what it looks like. It'll look like this. And that's 2, 3, 4, 5, 6, 7, 8, 9, 10. So it'll look like that. And similarly, for if you have integers or doubles here, then instead of empty quotation marks, it'll just be filled with 0 for strings, I mean for integers, and 0.0 for doubles. Now let's look at the second method. And for the second method, you're actually going in and providing the values directly. So the way that you do it is the type of the variable being used, and then you have an empty bracket, and then you have the name of the array that you want, and then you just start listing out the values. So you put in curly brackets, and you have, for instance, value, and then you could just have as many values as you need, and then that's how you will initialize array. So let's give you an example. Let's have string and then names as equal to, and then we put the curly brackets, and let's put our team members' names. So Kyle, Raj, and Freddie. And there'll be no and because it's just Freddie. And then you have a semicolon at the end. It's important to realize that each of these elements are separated by a comma. And let's go over how to count with the indices again. So Kyle would be indice 0, Roger would be indice 1, and Freddie would be indice 2. And the total length of the array is 3, but the indices only go up to 2. All right, so how do we actually interact with the array? What methods do we need, and what can we actually do with it? So remember at the beginning, we said that we couldn't change the actual size of the array, but we can change the values that we hold inside of the array. So the way that we do this is through the following notion. So you have the array's name here, and then you have the index that you want to change here, index that you want to change, and then you have an equal sign, and then you put the new value that you want it to change, that you want to change it to here. So one thing that's important to remember is that this new value has to correspond with the value that you set the data type that you set the original array to. So let's say you set the original array as a string. You cannot put anything else but a string as the new value. So you can't have an integer, you can't have a boolean, you can't have a double. It has to be a string. So let's use our example names and let's try to change these names to be more professional. So to change Kyle, because Kyle is in the 0th index and the name of the array is names, you do names and then you put 0 as the index and then the equal sign, and let's say Kyle Igaki to be more formal. And it has to have quotation marks because we're trying to make it a string because the original array is a string. And then semicolon, similarly for Raj, because Raj is in index 1, we put names 1, and then Raj Patel. And then let's try to change Freddie's name. Names 2 to Frederick. And that's how you would do it. And don't forget the semicolon at the end of each statement. So now let's show you something else that we could do that's pretty important whenever dealing with arrays. So let's get rid of this comment and let's actually initialize it. And again, let's change the names. Let's get rid of these comments so that you could actually see it change. So to access a part of an array, you can just do system.out.println, and then you could put, for instance, name 0, and let's see what it gives us. It gives us Kyle Igaki. Now let's do names 1, and it should give us Raj Patel. So that's how you access it. You have to put the name of the array and then the index that you want to reach. And another thing that you could do, which helps you with counting the indices and the number of slots you have, is actually look at the length of your array. So the way that we do that is by using this notion. So it's the name of the array, and then dot length. So in this case, the name of our array is names, and then if we do dot length, and let's say we system.out.println this, system.out.println this, although there are only although the indexes of our array only go up to 2, 0, 1, 2, there are 3 slots, so the length should give us 3. And as you see, it gives us 3. And what's important to realize again is that the indices will only go up to the length minus 1. And if you try to do, let's say, names 3, it'll give us an error because there's no such thing as the third index. And we'll see that here. It'll give us an error. So yeah, make sure you're careful of starting to count by 0. So now let's talk about our second data structure, array lists. So array lists are different from arrays, and they're usually imported from the Java utilities library. So at the top of your class, you'll probably see something called import array lists. So the difference between array lists and arrays is that array lists can change their size. So you can remove and add to the size, whereas in arrays you can't. So we usually use array lists when we're dealing with data that we don't know how much there most definitely is going to be. And it usually saves us space because let's say you're hosting a party and you invite 50 people, but you're not sure how many people will actually show up. So if you use an array, you would have to order, let's say, 50 plates, but you're not sure if anybody is even gonna eat those 50 plates. But for array list, you can just add plates as the people come along and then remove them as people leave. So let's talk about how to actually use this within our programming. So at the top, you would have to do import um, java.util.arraylist, and then that would be at the top. And now you can actually use your array lists. And the way that we declare an array list is by using this notion. So first you have array list, and then you put whatever type of data you want in this blank. So one important difference between array lists and arrays is that array lists can have multiple different types of data within their data structure. You know how we said that in arrays it could only be strings, it could only be doubles, it could only be integers. It's not the case for array lists. It could be a wide variety of those. So you don't necessarily have to put your data type in here if you're holding more than one. But let's just say, for example, we're only holding strings. And then after that, then you'll put the name of the array list. And that's just how you declare it. And it'll just be in your memory, but it won't have any variables assigned to it. And you have to initialize anything before you can actually work on it. Right now, it's just saying it's there, but you can't actually use it yet. So one example of this would be, let's say array list, and then string, and let's just say names. So in here, let's change this to data type. And that's an example of declaring an array list. So now let's go into actually how to initialize one. So you would do that by first doing array list, and then you put, let's put a sign saying that it's to initialize, and then you put the data type again if it's necessary, which means it's only necessary if you're gonna have only if you know you're only gonna have one type of data. If you have more than one, you don't really have to put anything here. And then the name of your array list, and then you put equal sign, and then new, and then array list again, and then you put these brackets again, and then the data type if necessary, and then you're gonna put some empty brackets and then a colon at the end. And that's how you initialize the actual array list. So let's use another example. So let's say array list, and then you have string, and then you have names equal to new array list, and then string, and then empty brackets, and then semicolon at the end. So now what's important to realize by most compilers is that it usually starts off with 10 slots, but it's not required that you use all 10 or that you only use 10 values. For instance, you can only use 5 or you could use 15, but the size of the array list will change automatically. So let's talk about how we actually interact with the array list. So first, to add values to the array list, you do the array list name, and then you put add, and then you put whatever value that you want to add in the blank to, and then that's just to add it to the end of the array list. If you want to add values at a specific index, so let's say you had 3 values and you wanted to insert it in the middle index, you would do the array list name, and then you would do add, and then you would have 2 blanks. So in the first blank goes the index that you want to add the value in, and the second one is the value. So let's just change this to value, and let's just change this to index, and let's just change this to value. Now for the third one, it's remove. So remove values, and then we're gonna put array list dot name, and then the name of it, array list name, and we're gonna put the index that you want to remove it. So dot remove, and then index here. And then to get a value at a specific index, you do array list name here, and then you do dot get, and then you put the index here. And similarly in array lists, you start counting from 0. So the first element is actually the 0th index. And then there's, to change the value, there is set. So you do the array list name, and then dot set, and then you put the index, and then you put the value here. And then lastly, to get the length or the size, actually in this case, of the array, it's different from to get the size of the array list. It's different from getting the length of an array because array lists have sizes and not lengths, if that makes sense. So size is array list name, and then dot size, and then empty parentheses. So that's an important feature to remember. In arrays, you use length, and in array lists, you use size. So now let's go over our third data structure, linked lists. And these next 2 data structures, linked lists and stacks and queues, will be more conceptual because their implementation is a little bit more advanced within Java, but the concepts are still important. So for a linked list, think of it kind of like a caterpillar. It's all connected and segmented. So let's draw an example. So let's just have 3 segments in our linked list. We'll have 1, we'll have 2, and then we'll have 3 here. And let's label this one A, let's label this one B, and let's label this one C. Now let's change the color just to make it easier to follow along. And yeah. So for a single linked list, we'll see these things. We'll see lines connecting them. So for a single linked list, each node, so this refers to a node, points to its next node. So it's giving the computer a direction to the next value. So A is going to point to B, B is going to point to C, and then C is going to have a null pointer because there's nothing after C. C is the last element. And that's for a single linked list. Now, if you have a circular linked list, which are usually used in like things that often repeat itself, now this last element or this last node will go back and point to the first one. But usually that's not the case. Now let's talk about a doubly linked list. So let's change the color again to orange. So now each node will have a pointer that points backwards and forwards. So it's going to point this way and this way. So now you can see that A is going to point to B, and then B is going to point to C and back to A. But A does not have anything previous, so now this one points to null. Null. And let's go back over here in the color blue. And let's label this one as having a null pointer as well because there's nothing for it to point to. So all in all, each node has three things. So first it has a value, which for this one it's A, for this one it's B, and this one it's C. Each one has a pointer that points forward, which will tell the program what's the next step. And then each one will have a pointer that points backwards. And for the cases of A and C, A has a backwards null pointer and C has a forwards null pointer because there's just nothing that comes after it. So the reason that we usually use linked lists within programming is because it's more efficient to remove and insert things. So let me give you an example. So let's go to a new page and let's say for instance you have an array or an array list since you're removing some value. You have 3, 4, 5, 6, and 7. And let's say you wanted to insert the number 4.5, right? You would have to do 3, 4, and then 4.5. And then for each of these values over, you would have to shift them all one to the right. And that won't really be that much of an issue if you only have 5 elements, but programs in real life can have up to like millions and even trillions of pieces of data. So that would take a really long time and a lot of computing power. So if you were to use linked list instead, and let's go back and let's draw a linked list for this scenario. We have 3, and then 3 is going to point to 4, and then 4 is going to point to 5, and let's say it just points to 6 instead of the original numbers. So it's going to point this way, this way. It's going to point this way and this way, and then it's going to point this way and this way, and this is going to point to a null, and this is going to point to a null. So if we're inserting 4.5 here, we can just get rid of this here. Let's erase this here, these pointers, and let's add our 4.5 here. Oh, let's delete this. Let's go to our pencil and let's turn fill off. I don't know how that got there. Turn the outline to 100. Let's say we put our 4.5 here. So now the pointer for 4 can just point to 4.5, and the pointer for 4.5 can point back to 4, and the pointer for 4.5 can point to 5, and 5 can point back to 4.5. So now instead of having to shift all of these values that are to the right of the 4.5, you can just change the pointers that 4.5 and 4 and 5 hold. And that's much simpler and takes much less time. So to see how we actually interact with the linked list, the methods are pretty similar to how we saw an array list, as array lists are usually what we built linked lists off of. But if you're curious, you could search up linked list and then documentation, Java, and then, for instance, Oracle and Geek for Geeks are very helpful and trusted platforms. So if you just went to Oracle website, you could scroll down and you could see what all of the methods and interactives that the class for linked list and the object for linked list have to offer. Now, lastly, let's talk about stacks and queues. So first, we'll go over stacks. So think of stacks kind of like stacking cups on top of each other. So let's just create an example really quickly. And let's say this is a cookie jar, for instance. And let's just change our color to uh, brown. So let's say you have cookie 1, cookie 2, and cookie 3. So the way that you actually insert these cookies, the order matters. So you're going to put in cookie 1 first, and then you're going to put in cookie 2, and then you're going to put in cookie 3. So cookie 1 is all the way at the bottom, cookie 2 is in the middle, and cookie 3 is at the top. So now let's say you wanted to reach out and get something out of the cookie jar. You would have to access 3 first. So 3 would go away, then 2 would go away, and then 1 would go away. So it's kind of like the opposite order that you put it inside of. So that's what a stack is. It's like stacking cups on top of each other as well. Like if you had a house of cards or cups, you couldn't take it off from the bottom. You have to start taking it off from the top. So now it's kind of the opposite for queues. So think of it as like a line, right? You have person one, person two, person three, person four, and the line is moving that way. So the the person that you're gonna take last, if you're taking away from the queue, you're gonna get rid of this guy first. And then this guy becomes the first in line, second in line, and then third in line. And let's say you wanted to add a person, the person cannot come to the front of the line and become number one. It has to come from the last, and it comes as number four. And again, let's say you wanted to remove somebody, then you would go in this direction and you would get rid of this person, and this person would become number one, this person would become number two, and this person would become number three. So the order that you goes in, the it's kind of the opposite for the stack. It's like a line. So let's really quickly talk about how we actually do this, or what methods that we can actually use within stack and queues. So let's just draw a sample stack really quickly. And one, two, three. So to add something on top of the element, it's called push. So to push something means to put it on top. And to get rid of the topmost element of a stack, it's called pop. So if you do pop, it'll return the value to you and it'll remove it from the top. Whereas if you just want to look at what it is, you just want to view it, it's called peek. So that's how you do it in stacks. And check if a stack is empty, you use dot is empty, empty. And then lastly, to check if it's full, you do is full. And those are the basic methods that you use within stacks. And then transitioning over to queues, if you wanted to add an element to it, which would come at the last. So let's just label these really quickly. One, two, three, and four. If you wanted to add an element to it, it'd be called NQ. That's what you would call it. NQ, NQ. If you wanted to remove an element, which it would take out this one, that's called DQ. And if you wanted to peek, if you just wanted to see what the first value was without removing it, that's called peek. And then again, there's also is empty and is full to see if this queue is full or not. And those are the basic data structures within Java. And they're pretty important to understand as you become more of an experienced programmer. And even in today's tech market, high holding jobs such as software engineers, they really value these data structures. And even if you pursue computer science within college, it'll be an important class that you take. So it won't necessarily harm you if you learn these concepts well better in the future. So hope you learned something and thank you for watching.